Okay, hi everyone, this is Mr. P, and today we're going to go over the Spearman rank difference correlation coefficient. I know that's a mouthful. All right, but anyway, this statistical procedure is going to be used when one or both of your variables are ranks or ordinal data. So the data is going to be ranked first, second, third, fourth, and we need to look at the data and compare their rankings. So an example of this would be looking at VO2 max and the order of finish in a 10K race. So let's say you had 20 individuals and they were running in a 10K race, and you had which place they were in, first, second, third, fourth, fifth, and you had their VO2 max values, and you wanted to see if there was a correlation between placement in the race, the 10K race, and their VO2 max. You think there would be a relationship between those two variables. So this is the formula that we use when we calculate. You can do this by hand, or we're going to show you how to do it in Excel. We're going to show you the easy way to do it in Excel. All right, so how we're going to do this is we're going to list each set of scores in two separate columns. And then we're also going to create a column with the score rank for the two sets of scores. In Excel, we're going to be using the function called RANK.AVE, and this is an easy way to get the score rank for a data. So I'll show you how to use this function to make your life a little bit easier when you're actually calculating the score rank. Remember, when you're doing score rank, identical scores are going to get the same score rank, and you'll see that once we pull up our Excel spreadsheets. Okay, once you have the score ranks figured out for your data, you're going to create a column, which is going to be your D column, and this is the difference between the ranks, okay, between the paired scores. So it's going to be the difference in, for example, the rank that the person finished the race in and the rank of their VO2 max. So we're going to be comparing those, and we're going to be taking the difference. Of course, we're going to have to square that because we want to remove any negatives. And then, of course, we're going to be calculating the correlation coefficient from that. All right, so I know it sounds like a lot, but it's not that bad. We're going to use Excel to make our lives a little bit easier. So again, this is the formula that we are using. It uses the Greek letter rho, and that is going to represent a Spearman rank difference correlation coefficient. All right, so let's take a look. Okay, here is our Excel spreadsheet. So this is a blank one, and over here you can see I have these columns set up. And if you don't know how to do this in Excel, you definitely want to learn how to do this. You want to learn how to format your data, how to format your rows and columns, how to add colors, how to add these grid lines. These are all things that are pretty basic skills when you're using Excel. So I've created some columns and I color coded them to make the data a little bit easier to see. And you'll notice I have my two sets of scores. I'm looking at how this person finished in the race. First place, second place, third place, fourth. And I'm looking at that individual's VO2 max. All right, and remember, these are paired scores, so these scores have to stay paired together. That's very important. You can't separate these scores because this is an individual, so you can't separate how this individual did in the race and their VO2 max. All right, so let's go ahead and fill these columns in. Now over here, this is the score rank for how they placed in the 10K race. And since this data is already ranked, it's ordinal data, we can just pretty much copy this data and paste it into this column. So we can just go ahead and select all this. I'm going to right click, copy that, and then I'm just going to go ahead and paste that over here. So let's paste that in right there. Okay, now there's other ways of doing it. You could use a formula, but actually, since that's already ordinal data, we're just going to go ahead and put it over here in this column. And you notice that there are no two identical scores, so we just pretty much copy and paste. Okay, now over here, all right, we need to figure out the score rank for the VO2 max. Now, normally what we do is we put all of the scores in descending order from highest to lowest, and then we go ahead and figure out the score rank. Now, you can do it by hand, but I'm going to show you how to do it in Excel easily with that Excel function called RANK.AVE. So if you're going to do it by hand, what you need to do is you'd have to create some columns. You have to add a couple columns to your Excel spreadsheet. So that's what I did here. I created 3 extra columns. And in the first column, what I did is I took the VO2 max data and I put it in order from highest to lowest. And then what I did is I figured out the score rank of this data. So 60 was the highest VO2 max, so it got a score rank of 1. And then here's 58. That was the second highest VO2 max, so it got a score rank of 2. And then you see here we have 2 56s. So these have to get the same score rank because they're identical scores, right? So we take the average. So this was third and fourth. So if we average 3 and 4, we get 3.5, 3.5. So they're both going to get the same score rank because they are identical scores. All right, if we go to the next VO2 max, we have 53, 53, 53, and 53. We have 4 that are identical. Okay, and this correlates with a score of 5th, 6th, 7th, and 8th. So what we're going to have to do is average 5, 6, 7, and 8. We're going to have to average that. And when we average 5, 6, 7, and 8, the average or the score rank is going to be 6.5. So all of those are going to get the score rank of 6.5. Okay, so that's how you do it. We already talked about how to do score rank previously, but that is how you would do it if you are doing it by hand. Okay, and then of course you have to carefully place this number with whoever scored the VO2 max of 60. So again, if you were doing this by hand, you'd have to look, okay, a VO2 max of 60 gets a score rank of 1, but which of these individuals was the one with a 60? It's this person right here. So you'd have to put a 1 right here. So it's very time consuming and there's a lot of room for error when you do this by hand. So we want to try to avoid doing that by hand. We want to use a function in Excel to figure out the score rank. So let's show you how to do that the easy way. Okay, so let's go ahead and hide this. Just going to hide all that. And let's go ahead and clear that out. So what we're going to do is we're going to create a function. So we're going to go to formulas. We're going to insert a function. And the function we're looking for is called rank.average. So we're going to select that. And here you can see kind of the explanation or definition of this function. All right, so it's going to give the rank of numbers in a list of numbers. Okay, and if they have the same score, it's going to average the rank. Okay, and that's what we want when we're doing these problems. So we're going to hit OK. All right, so then you're going to get this function arguments box where you get to input the data. So what number are we trying to figure out? We're going to go ahead, we're trying to figure out this number right here, 56. So we're going to go ahead and select this input box, and we're going to select this cell right here with the score of 56. So we're going to select that, and we're going to put it into the function. And then the reference, this is the entire set of numbers that you're going to reference this against. So it's going to be all of these VO2 max scores. So we need to select all of these. So we're going to go ahead and select the input box, and we're going to highlight this entire column, and we're going to input that into our function, and then we're going to hit OK, and you'll see that this individual got a score rank of 3.5 for his VO2 max. All right, so again, this was how they placed in the race, and this is how they rank based on their VO2 max. All right, now normally once we have a function created, we just drag it, right? We just drag it and it Excel will automatically fill in these empty cells, but if you do that, you're going to run into a problem. Watch. Oh boy, this doesn't look right. These numbers do not look right, right? So what's going on here? Well, as we drag it, it's changing right here. It's changing the actual range of numbers that we're looking at, and we don't want that to change. We want it to include all of this data. So how do we modify it so it doesn't change the range of VO2 max scores that we're looking at? Well, let's go ahead and get rid of all this, because this actually is incorrect. All right, what we're going to do is we're going to go up here to this formula, this rank average formula, and we're going to add a couple dollar signs in here. When you add dollar signs to a formula or a function in Excel, that is creating an absolute cell reference. So what that is telling Excel is, do not modify this. Keep this exactly as I have it written in this function. So I'm going to go ahead and put a dollar sign in front of the C. I'm going to put a dollar sign in front of the 2. And then over here on this side, again, this is a range from C2 to C21. So it's that range of scores. I want to keep that range. I don't want it to change. So putting these dollar signs in front of these values will ensure that Excel does not modify that part of the function. All right, so now I'm going to go ahead and put input, hit the checkbox, and again, it stays 3.5. Now, when you drag this down, you're actually going to get the correct score ranks, because as you dragged it down, the range of scores that you're using as your reference is not changing, because we added these little dollar signs to our formula. That's very important to know. It's easy to miss that and completely mess up your formula when you drag it. All right, so there it is. It's that fast, it's that simple when you use that Excel function. Again, it's called rank.average. All right, so now we have our ranked data, and what I'm going to do, I'm actually just going to hide these right now, the actual raw scores, because we're looking at the rank score. We're comparing these rank scores. So we're going to go ahead and figure out the difference. Okay, we're looking for the difference. So in this column, I'm going to go ahead and start my equation with an equals sign. We always start equations with an equals sign in Excel. And I'm going to go ahead and select this cell reference right here. And I want to subtract this cell reference, okay, the VO2 max score rank, right? And then I'm going to hit enter. And that is the difference, okay? So I'm subtracting this column, and this is the difference that I get. Now, once I have that formula input, I can just drag this down, and it will complete all of those for me. So it's subtracting this number from this number, and this number, okay? So you understand how that's happening in Excel. Now, I want to get rid of these negatives. I don't like these negatives over here. So we're going to get rid of those. And how we're going to do that is we're going to square the difference. We're going to square this set of scores. So over here, again, in the d squared column, we're going to start our equation with an equals. We're going to go ahead and select this cell reference right here, and we're going to square it. So we're going to add a caret, which is Shift 6 is the caret. That means raised to, okay, the power of 2. So that means we're going to square whatever data is in this column right here. So we're going to go ahead and put enter. All right, now we're just going to grab this drag handle, and we're going to fill in all of these empty cells. And there we go. We have all of the squared data. All right, now down here at the bottom, okay, for our formula, if you see our formula here, this is our formula. Let's move it over here so we can see it clearly. We need to summate all of these d squared scores. All right, so all of this column, we need to sum this column. So what I'm going to do is I'm going to go ahead and select this box that I created. I'm going to go to auto sum right up here. And it looks like, yep, all the scores have been selected for me. I'm going to hit enter. and I'm going to get an answer of 88. Okay, so 88. And we're going to add that to our formula. So here is the formula written in Excel. All right, that's what it's going to look like. So I'm going to go over here, and this is our 1 minus, okay, so here's the numerator is going to be 6, and I like to put things in parentheses. So 6 times, okay, that's your asterisk, times, okay, this cell data right here. So I'm going to select this cell with the summation of the d squared scores, okay, and then I'm going to end my parentheses, all right, and then I'm going to enter that, right, and you'll see what we get for our numerator, 528. And then down here on the bottom, I'm going to create a formula that's going to mimic this denominator, okay, all of this down here. Now, I do need to have the n value. I do not have the n value calculated. So let's go ahead and calculate our n value. So I'm going to put n right here with an equals. All right. And actually, I'm going to make it a little bit bigger so I can see it clear. Good. And I'm going to go ahead and set it over to the right like that. So n equals. And what formula or function do we use to count up data? You guessed it, it's the function count. So I'm going to go to count. I'm going to hit OK, and I'm just going to select this and hit OK, and n equals 20, and that is correct. We have 20 individuals. We have 20 sets of data. So let's go ahead and make that nice and bold. All right, so n equals 20. All right, so n is 20. So let's go ahead and put that into our formula. So over here, we're going to select this cell. We're going to put an equal sign in there. That's telling Excel that this is going to be a formula. All right, so it looks like we need n. So I'm going to select this cell because this is telling me what n is. So I'm going to select this cell right here. Okay, so again, n is 20, right? And that is times. I'm going to create another parentheses, and it's n squared. So I'm going to select this cell again because this is the n value. We're going to raise that, so I'm going to go caret 2. So that means I'm going to raise it to the second power, and then I'm going to subtract 1. I'm going to end parentheses, and then I'm going to add parentheses for the entire denominator equation. So let's go ahead and, okay, there it is, and that's the value that we have. So here we have our Spearman coefficient equation right here. So let's go ahead and calculate this and see what we get. All right, so right here, our rho value is going to be this equation. Right, so let's go ahead and figure out what it is. Okay, we can hit an equal sign. Okay, and we're going to go, I like to start things with parentheses, 1 minus, again, parentheses. We're going to select the numerator, which is this value here in this cell, divided by the denominator, which is the value that's in this cell. We're going to end parentheses, and then we're going to get the whole equation in our final parentheses. All right, so that should be it. Let's hit enter and see what we get. We get a rho value of 0.934, which looks like it is probably correct. Remember, it's going to be somewhere between a positive 1 and a negative 1. Okay, if you get a rho value or you get a Pearson value of 2.6, whatever, you know you did something wrong. Because again, your rho and your Pearson value are always going to be between a negative 1 and a positive 1. All right, so that's it. That is our rho value. All right, now once you figure that out, you could go ahead and look this up in the chart in the back of the book to see if this is statistically significant. Just looking at that value, just knowing how high that value is, I know that that value would be considered statistically significant just by looking at it. Okay, but if you wanted to actually look this up, I'll show you how to do that. Okay, here is our appendices in the back of the book. This is Appendix A. And these are the values of the correlation coefficient, generally used for the Pearson, but we can also look at this for our rho value. And you would figure out the degrees of freedom. So in this example, okay, in this example, we have 20 individuals, so the degrees of freedom would be 18. Right, so we're going to go over here, we're going to look up 18, so degrees of freedom are 18. So we're going to start over here with an alpha value of 0.05. So again, is our value that we calculated higher than 0.444? And it is. So we go over to the alpha level of 0.01. Is our value that we calculated higher than 0.561? And it was. Okay, it was 0.934. So is there a statistically significant relationship between these two variables, between how a person finished or scored in a 10K race and their VO2 max? And from this problem that we just worked out, we figured out that there is a statistically significant relationship between how a person places in a 10K race and a person's VO2 max. Right? So there you go. That's how we do it. So that is called a Spearman, okay, rank difference. Again, this is used when you have ranked or ordinal data. Okay, either both sets of data are ranked or ordinal, or you have one set of data that is ranked and the other set of data is like the raw scores, the raw data. And you have to convert that to a score rank, which is what we did with the VO2 max in this example. All right, so that's how we do it using Excel. It's not too bad. Hopefully this video was helpful. You can go back and watch how I did it, how I created those formulas in Excel. It's just one of those things you have to play around with. I just absolutely love doing this in Excel. It just makes your life so much easier when you're running these statistical procedures using those functions. All right, everyone. I hope that was helpful. In the next video, I'll show you how to graph this. All right, that is it. I hope everybody has a good night. Take care, and I will be talking to you all very soon.